522or.ie. Which of the following scatter graphs shows a negative correlation? A, B, C, or D? Scatter graphs are similar to line graphs in that they use horizontal and vertical axes to plot data points. However, they have a very specific purpose. Scatter graphs show how much one variable is affected by another. The relationship between two variables is called their correlation. Scatter graphs usually consist of a large body of data. The closer the data points come when plotted to making a straight line, the higher the correlation between two variables, or stronger the relationship. If the data points make a straight line going from the origin out to high x and y values, then the variables are said to have a positive correlation. If the line goes from a high value on the y-axis down to a high value on the x-axis, the variables have a negative correlation. Taking a look at the examples, the first example was that the straight line goes from the origin out to high and x and y values. This is the example shown in this graph, where as the x values increase, y value increases as well. Taking a look at the second example, where the line goes from a high value on the y-axis down to a high value on the x-axis, that is talking about this example, where it starts off with a low x value, and as x increases, y is decreasing. And so these two are known as the examples of perfect positive correlation and perfect negative correlation, where the data points are absolutely lying on the same line in each case. A perfect positive correlation, by perfect we mean that they all lie on the same line. A perfect positive correlation is given the value of 1. A perfect negative correlation, again, a perfect negative correlation means that all the data points are lying on the same line, is given the value of -1. If there is absolutely no correlation present, the value is given 0. The closer the number is to 1 or -1, the stronger the correlation. In other words, stronger the correlation means stronger the relationship between the variables. As we can see, this is a line of perfect positive correlation, where all the lines line up on the same line, straight line. This is an example of a high positive correlation, where most of the lines have a general trend of being in the same direction. As one goes up, the other also goes up. But they are not all lying on the same line. This is an example of a low negative correlation, where if you take a look with your eyes, you can see that there is a general trend where as the x is increasing, y is decreasing. There is some kind of a hazy difference as it goes down, like this. But there is no particular line that the points seem to be coherent to. And so that is known as a low negative correlation, where the points are not necessarily all on the same straight line, but you can just about see that there is some kind of correlation. The closer the number is to 0, the weaker the correlation. So let us draw a straight line and draw a scale on this line, where we have in the middle is marked and the tip, and so we have at the top, let's say we have positive correlation. So the top of the scale would be perfect positive correlation. And this would be given a number 1. On the other end of the scale, we'd be having perfect negative correlation. And so this would be given a value of -1. So somewhere in the middle would be where you have no correlation at all. And so we write no correlation. And this is given a value of 0. So the closer the number is to 0, the weaker the correlation. So that means, as you can probably imagine, somewhere in over here would be weak positive correlation, and we have weak negative correlation. And so as you approach to 0, the correlation gets weaker. Here is again an example of a high negative correlation, where the correlation is negative, and a lot of the points seem to be lying on a similar line that goes down. And so for a graph like this, you would be looking at a region somewhere around here. In this example, as x is increasing, the y values on the data points seem to have absolutely no connection at all with the x values. At each data point, there seems to be absolutely no correlation between the x and the y values. This is an example of no correlation, and this would be given a correlation number of 0. So, going back to the original question, the data on the graph on option B seem to be going in a general direction, or a general trend of going towards down. As x increases, y seems to be going down. And so this is an example of negative correlation. And this was the B answer. And so this was the graph, which is the correct answer for the most likely to be the negative correlation graph. So that is the correct answer.